Good day, guys. I hope you're all doing so well. So before you can watch this video, can you please like and subscribe so that you can receive more updated content each and every week for the benefit of your success in your academics. So just subscribe and like this channel for you to receive more content each and every week. So today you're going to do trigonometry examinable questions. So we're going to do general solution, compound angles, simplifying angles, proving identity, and some other few questions that are examinable, guys. So today let's start with general solution, our first question. So guys, this we have 2 sin squared x minus 5x, minus sin x plus 2 equal to 0. Ne? So this one I'm gonna simplify it. I'm gonna apply basics in this one. So for those ones who cannot open brackets and take out factors or common factors, I'm here for you guys. So I'm gonna make everything simple. Ne? So in this case, you can simplify it in a way that is so simple, guys. Ne? I'm gonna show you right now. So we have 2 sin squared x minus 5 sin x plus 5 plus 2 equal to 0. This is a quadratic equation because there are 3 terms and there's a squared here, meaning here you must open 2 brackets of sin x. Can you see, guys? We have first term that is squared, we have second term that is it is basically like this. I'm gonna write the basics of quadratic equation: a squared plus bx plus c equal to 0. So our a is our a has squared, sin squared. Our b, it has sin x, negative sin x, then there's x here, then 2 our constant equal to 0. It is basically quadratic. Ne? So you need to apply what you know about quadratic, guys. But I'm gonna make everything simple. Ne? So first thing first, I'm gonna do right here. If you can take out factors, or you can open 2 brackets of this equation or this quadratic equation, just say let sin x be equal to perhaps let me just say y. Basically where I see sin x, I need to put in y. Sin x, this y in it. So we're gonna have 2y squared minus 5y plus 2 equal to 0. I hope you understand, guys. Then right now I'm gonna use trial and error method. Trial and error method. How does it work? It means I'm gonna start from 0 up until a number that gives me this 0. When I substitute where I see y, I'm gonna put in 0, 0. Then if it does not give me 0, I go to 1. If I put in 1 here and does not give me 0, I go to -1. If -1, it does not give me 0, when I substitute here and here, I go to 2 until you get a number that gives you 0 in this case. So guys, if you put in let me just use a calculator. Even on your side, you must try to use a calculator to make sure that you are on the right track. Let me just start with 0. 2 times 0 squared minus 5 times 0 plus 2. It gives me 2. That means it's incorrect. Even if I can go to 1, even if I can go to -1, it's not gonna give me 0. Let me just put in 2 here. Let's just put in 2. 2 times 2 squared minus 5 times 2 plus 2 equal to, it gives me 0. That means 2 is correct. I mean 2 is a factor of this quadratic equation. 2. So I'm going to put in its bracket y minus 2. Y minus, and here we've got the positive 2. When you substitute here, it means if this -2 comes out of the bracket, it is going to become positive 2. Hence it's y minus 2. But if generally 2, or if you have -2 here, if you have substituted -2 here, then it's gonna give, then if it gives us 0, then you're gonna put in positive 2 inside the brackets. That's so that when it comes out of the bracket, it relates to what is in the calculator, or what is shown on the calculator. Ne? So we must just check like that, guys. The signs must differ basically. When it must differ from that one that is outside the bracket. Ne? When it is inside the bracket, it does not change the sign from positive to negative or from negative to positive. Ne? So that when it comes outside the bracket, it's going to become positive 2 that you got on the calculator. Ne? Yes. Then y minus 2, it's a quadratic, open another bracket. What are factors of 2y squared? Which number can I multiply with y to give us 2y squared? 2y, I get, because 2y times y is 2y squared. Then which number can I multiply with negative 2 to give us positive 2? Minus 1. I get negative 2 times negative 1 is positive 2. Then you close the bracket, you equate it to 0. Do you guys understand where does this come from? You guys understand? If you don't understand, just come to my inbox, or yes, my WhatsApp inbox or my email, or even on the comment section, so that you can tell me what you don't understand it, so that I can explain it further for you guys. Now, so right now I'm done with factors. Let me just go back to sign right now. Sign again. Let me just substitute. Where I see why I put in sign. Just I'm bringing the original equation right now here. So y for y is sin x minus 2. For y again is y sin x. And here it is longer y squared. Hence there is no squared here. It's only y. Hence we have sin x minus 1 equal to 0. Then I'm going to equate the two brackets to 0. You already know that. Sin x minus 2 equal to 0. Or 2 sin x minus 1 equal to 0. Then sin x equal to 2, or sin x equal to 1 over 2. I distributed this negative 1 to that side. It's going to be positive 1. Then I divided by 2 on both sides. It's going to give us 1 over 2. Hence I got sin x equal to 1 over 2. Then guys, general solution, you need to have solutions of this ratio. Ne? So I want x here, and here if I'm gonna have sin negative 1, 2, and here on a calculator this inverse of sin, and get that where you see sin to power negative 1. That's where you're gonna say shift on the calculator, and there's sin negative 1. It's gonna show like this. Then you put in 2 inside the bracket. Then if you find the solution of this thing, there's no solution for the inverse of sin 2. No solution. Or in this case, we have x equal to sin to power negative 1 over 2. The inverse of sin times 1 over 2. So the answer is 30. X equal to 30. We're not done, guys. General solution, meaning we need to find other possible solutions for this equation. Then let me just make everything simple for you. If you want another solution for sin x, let me just draw a Cartesian plane. Guys, our sign is positive, and it here from here our sign is positive. It is not negative. If it was negative, we're gonna change it obviously. Then we're gonna say 180 minus 30. If it was negative, but now it's positive, there's no need for you to change anything here. And our value is 30. It means 30 is on our first quadrant. Then you're gonna check again whether sign is positive. On which quadrant is sign positive? On which quadrant cast sign is positive on this second quadrant. Then our next solution is gonna be, before that, 30 plus k times 360, and get such that k is the element of z, or is element of integers. Then x is equals to our second quadrant. It's 80 minus x. 80 minus x. What is the value of x? Is 30. Meaning gonna say 80 minus 30 plus k times 360 such that k is the element of integers. Then x equals to 150 plus k such that 360 just that k is the element of integers. You are done, guys. These are the two solutions. You are done. If this negative 1 over 2 is what was negative, you're gonna check ukuthi on your side is sign negative on this quadrant and this quadrant. You're gonna say 270 minus theta, then 360 minus theta. Then you're done, guys. You find the value of this quadrant and this quadrant. With the use of this value, you could have got, when you have simplified this, when 1 over 2 was negative only, guys, you're gonna say third quadrant and fourth quadrant. Then you're gonna find solutions on both quadrants. Then you're gonna put them here. Then you're done. You guys fine? Let's just go to the second question. Okay. So question 2, guys, is so simple. We're still continuing with trigonometry. So it says that you must expand the sine of x plus 300 using appropriate compound angle formula. Do you remember what is a compound angle, guys? So this is the basic or standard formula of compound angle for sine. I get sine of a plus b perhaps equal. So meaning if you expand this compound angle, you want to say sine of a, then cos of b. The signs are the same. For sine, the signs are the same. Then cos of a, then sine of b. You are done. That's expanding this compound angle. So now let's come here. Let's simplify this, or let's expand sine of x plus 300 and get sine of x plus 300 degrees equal to sine of x, then cos of 300, signs are the same, cos of x, then sine of 300. You are done. It is expanding, guys. You are done. Then now let's go to another question. Question 2.2. It's so simple. Without using a calculator, determine the value of sine x plus 300 minus cos of x minus 150. Then you close the bracket. So we must simplify this. We must determine the value of this expression. Let me write it correctly, guys, or let me write it in as an individual expression. Minus cos x minus 150 close bracket equal to. This one is so simple, guys. You've already expanded sine of x plus 300. Here it is. We're gonna write it as it is here. So sine x cos 300 plus cos x sine 300. Minus open bracket square bracket. You're gonna accommodate this negative, hence I open a square bracket and get cos of x. Now we're expanding the compound angle of cos and get cos sine and get cos. The signs are gonna change, gonna be plus, then sine x sine 150, then close the bracket. Simple. So what you're gonna do right now, you're gonna simplify our angles. This 150, we don't want to, let's just simplify them and see ukuthi sisozipha kuphi itlogisa kae. So you're gonna have sine x, then guys cos 300 is on the fourth quadrant, and fourth quadrant cos is positive. So you're gonna have cos of 360 minus 300 is 60. 360 minus 60, you are done, plus cos x. Then you have sine on our fourth quadrant. What's the sign of sine? It's negative, and on our fourth quadrant you're gonna have 360 minus 60. You want to change this sign because sine is going to be negative on our fourth quadrant. Yeah, are you okay, guys? Then minus, open our bracket, cos x. Cos on the second quadrant is negative here, so we're going to have a cos of 180 minus 150, 180 minus 30. And here, guys, plus sine x multiplied by sine of sine is positive on the second quadrant in 180 minus 150 is 130. Is I mean 180 on our second quadrant minus 150 is 30. So it's gonna be 180 minus 30. Then you close bracket, close the large bracket in it. So guys, you must write, as I simplify this example, you must also do, or you must also help me to simplify it on your own so that you can see what are you gonna get it right or wrong. Yeah. So now cos on our fourth quadrant is positive. That means there's no need to change the signs of this term here. So it's gonna be sine of x cos of 60 plus sine on our fourth quadrant is negative. That means we're gonna have this term is gonna be negative. And let me just open a bracket, negative cos x sine 60, meaning I multiply this negative by positive, of course, hence we have negative cos x sine 60. This negative comes from this part of sine 360 minus 60, because sine on our fourth quadrant is negative, hence we have negative here. Close bracket minus cos on our second quadrant is negative, so we're gonna have negative cos x cos 30, meaning this negative is going to affect this term as it is. This negative, it comes from here because our cos on our second quadrant is negative, and hence we have negative here, plus sine on our second quadrant is positive. That means it's not going to change this sign. We leave it as it is. Sine 30. Then we are done. We close the bracket. Equal to sine x cos 60 negative. Positive by negative is negative. Cos x sine 60. Negative by negative is positive. Cos x cos 30. Negative by positive is negative. Sine x sine 30. Guys, when you reach this point, you can use co-functions. It's not a problem, because even if I can change this, and if I use co-function of cos 60, gonna be 90 minus 30, then this bracket is gonna be the same as this one. Or you can simplify it by the use of special angles. Cos 60 sin 60 30 are special angles. So when you use special angles, you're gonna get it correct. Also, I can use co-functions by changing this term or this one, even this one or this one. I can change them so that I can make sure perhaps at some point I need to subtract my terms so that I can get the value. I need a number, not a function or a ratio. And I don't need a trigonometry ratio. I need a value, a constant or a number. My final answer should be in numeric, not with some ratios, because they said you must determine the value. You must calculate. Without using calculate, you must determine the value, a numeric value. You don't need a function here in our final answer. So there are many ways to simplify this expression. There are many ways. So let me use the simplest way you can use. Perhaps, guys, I Okay, let me use cofunctions now. Cofunctions here. So how do I use them? I need everything to correspond with each other. I mean, I need to make everything to make sense to us. Né? So there's sine and cos here. There's sine and sine, meaning even if I can have cos 60, if I say 90 minus 60 is going to be 30, that means this bracket is going to cancel this part. I mean, this term is going to cancel this term. That means I might be getting to the right or correct path. Né? So even if I can come to this term of cos x sin 60 and this one, I can use cofunction to remove the sign by saying cos of 90 minus 30. Then this bracket is going to cancel this bracket, or this term is going to cancel this term. Let me just do it, guys. So sine of x, cos, cofunction of cos is going to be sine. I just when it changes, it's going to have sine of 90 minus 60 is 30, minus 30 minus, let me just change this 2 né, so that it can make sense to all of us. Cos of x, cofunction of sin 60 is cos of 90 minus 30. Well, it makes sense to me, guys, and maybe perhaps to all of us it's gonna make sense at the end né? Plus let me leave this 2 because there's no need for me to change all the terms. There's no need. Cos of x, cos 30 minus sine of x, sine 30. Then let me just write it everything properly. Sine of x, 90 minus 30 is sine 30 minus cos x, 90 minus 30 is cos 30. There's no need to change the signs because 90 minus is on a first quadrant, and every trigonometric ratio on the first quadrant is positive. And get yes, each and every trigonometric ratio on our first quadrant is positive. Hence, there's no need for change of signs. So yeah. So guys, let us apply mathematics here. You know, good. This term is the same as this one. So you can say sin x sin 30 minus sin x sin 30 0. Negative cos x cos 30 plus positive cos x cos 30, it's 0. That means the final answer is 0. You're done. I hope you understand, guys. You can use special angles to simplify. You can come here and use special angles. You're still gonna get 0. Yes. Let's just go to question 3. Question 3, guys. It says that you must prove the identity tangent x plus 1 all over sin x tan x plus cos x equal to sin x plus cos x. You must check which side is complicated. Obviously, our left hand side is complicated. That means or is the one that needs our attention. Let's just simplify our left hand side, because our right hand side does not need anything. Like, you cannot do anything to this one. It's like this. That means our final answer on this side should be the same as this one. It's a must, because there's nothing we can do on our right hand side. It's just like this, our right hand side. Né? So let's just simplify our left hand side. Our left hand side, we have tan x plus 1 sin x times tangent x plus cos of x. Simple, né, guys? So guys, apply what you know. Applied identities that you know. You don't need to confuse yourself in this one. Né? We have tan x here. Let's just try to change it. Let's change what we know. Let's apply the basics of what you know. Né? Tangent x, obviously, it's gonna be sin x all over cos x plus 1 all over sin x multiplied by tangent x. It's gonna be sin x all over cos x and here plus cos of x. Simple, né? Then our top bracket, we have 1 over 1 again. So You must remember that whenever you have plus or minus here, just take out the LCD, lowest common denominator, here on our numerator. What is our LCD on our numerator? How do you find LCD? You multiply our denominators, cos x times 1. That's our LCD. It's called to cos x. That's how you find LCD. Then let's just apply LCD. Cos x. We are here right now. We are here. On this one, we are here. Let's simplify our numerator. Cos x. Meaning, how do you simplify our numerators, or after you have found our LCD? You put it on our denominator, on this fraction here. So we're gonna say cos x divide our denominator times our numerator. Our LCD divide our numerator. Our LCD divide by our denominator times our numerator. You must remember that, guys. After you have found the LCD by multiplying your denominators, you put it on this side, then, or on this position. Then you're gonna see our LCD divided by our denominator times our numerator. Cos x divided by cos x is 1. 1 times the next is sine of x. Cos x, okay, plus cos x divided by 1 is cos x. Cos x times 1 is cos of x. All over. You come here. Sin x over 1. I get sin x times sin x, sine squared x. 1 times cos x all over cos of x plus cos of x all over 1. Do you understand, guys? We come here again. Now our numerator, let's just leave it for now. Let's just leave it for now. We're gonna come back to it later. All over cos x divided by same, we have positive here. Let's just take out our LCD. How do we take out our LCD, or how do we identify our LCD? By multiplying denominators. Cos x times 1 is cos x. That's our LCD. Cos x divided by, we come to our denominator again. LCD divided by denominator times times numerator. LCD denominator divided by our numerator. Our LCD times our numerator divided by our numerator. Cos x divided by cos x is 1. 1 times sin squared x is sin squared x. Cos x divided by cos x is cos x. Cos x times cos x is cos squared x plus cos squared x. Simple, guys. Then now, guys, we are playing basics here. Perhaps there's nothing you don't know here. You know everything that I'm applying. It's just basic maths. From grade 8 LCD, to grade 10 identities. Simple, but you're in grade 12 right now. Remember, this is May June 2017 exam, paper 1. Paper 2 of mathematics. And you're in grade 12. You're already applying basic maths of grade 8 to grade 10. Or let's apply basics. Still, right now, let's just leave our numerator because we still have something that is confusing us on our denominator. Let's just leave our numerator for now. Apply what makes sense to you. Simple. Because if you can divide our numerator, it's not going to make sense. It's going to bring you back here. So you don't need to pay much attention to our numerator for now. Sin x plus cos x all over cos x all over sin squared x plus cos squared x. Basic is 1 again. Identity. There's no need to debate it. It's 1 over cos x and it equal to. Now, guys, we apply basics again. There's this thing called KFC. Keep the first, flip the second, and change the sign. So guys, in this case, we have, when you apply KFC, when you have many fractions, we have two fractions here, guys. So let's apply KFC. KFC must say, it says that you must keep the first fraction, meaning you must keep your denominator as it is. Let's just keep it sin x plus cos x all over cos x. Then we are okay. Then flip the second, meaning we must flip our denominator, meaning cos should be our numerator, then 1 should be our denominator. But before that, you need to change the sign. This is division. While the opposite of division is multiplication. Then flip the second fraction. Cos x is going to be our numerator, then our 1 is going to be our denominator. So cos x divided by 1, and yet then we are here right now. Guys, in this case here, when my numerator is the same as our denominator, when you multiply, you can divide our numerator and our denominator. Meaning I can divide this term by this term because they are the same. And I'm multiplying here. It makes sense for me. Cos x divided by cos x is 1. Then you're going to be left with sin x plus cos x. Then we are done, guys. This is the final answer for our question 3. I hope you understand where we come from. If you don't understand, come to the comment section and ask your question. Now let's go to our perhaps last question 4. So guys, our fourth question, it says that you must consider sin x plus cos x equal square root of 1 plus k. 4.1, determine k as a single trigonometric ratio. Simple, just find the value of k. Just find what is the value of k. Simple. Simplify. They're basically saying you must simplify k. You must find the value of k. Simple. But that value of k must have some trigonometric ratio in it. So let's just find k. What's the value of k? Simple, And here we have sin x plus cos x equal square root of 1 plus k. How can you solve for k? We have a square root here. How what like k right now, guys? We need to eliminate each and everything that hinders us from finding the value of k. We have a square root here, guys. How do you simplify, or how do you remove the square root? By introducing squared on both sides. Simple, Then you're gonna be left with 1 plus k. Then if you simplify this thing, you're gonna have if you can simplify it on your own, guys, you're gonna be left with, you're gonna open 2 brackets of sin x plus cos x and use FOIL. Meaning you're gonna use FOIL, multiplying out brackets. You're gonna be left with sin squared x plus 2 sin x cos x plus cos squared x, and yet then sin squared x plus cos squared x plus 2 sin x cos x equal to 1 plus k. I wanted to write these terms so that you can see when you simplify them, you're gonna get 1. Or when you change, or when you use identity, you're gonna get 1 when you have these 2 terms in one place. Hence I have rearranged them. So it's gonna be 1 plus 2 sin x cos x equal 1 plus k. Simple math, you're gonna be left with k on one side. Let's transpose this one to the side. So you're gonna have 1 minus 1 plus 2 sin x cos x equal 1 plus k. 1 minus 1 is 0. We're left with 2 sin x cos x equal to k. The question said that you must write k as single trigonometric ratio, meaning we must have single, we must not have sin and cos. We must have single trigonometric ratio. Do you remember, guys, the identity of this term? Can you please give me in the comment section what's the identity of 2 sin x cos x? 5 seconds. What is the identity of 2 sin x cos x? Because this question that must write k as a single trigonometric ratio. We must not have 2. Now you have 2, you must have 2 with 1 trig ratio. How do you solve it, guys? Remember, 2 sin x cos x is the same thing as saying sine 2x equal to k. We are done. This is the value, or this is how we determine k and write it as a single trigonometric ratio. Then, are we fit enough to go to 4.2? I think yes. This is the last question, guys. 4.2. It says that hence determine or determine the maximum value of sin x plus cos x. Do you guys understand? Hence determine the value of, or the maximum value of, sin x plus cos x. Okay. So guys, let's just go back to this one. Remember, sin x plus cos x equal to square root of 1 plus k. You're going to use this thing because they say that you must determine the maximum value of sin x plus cos x, meaning you come here again. What is the value of sin x plus cos x? It is square root of 1 plus k. Let's just write it here. What is the value of sin x plus cos x equal to the square root of 1 plus k? They say that you must use hence. If they say hence, it means you must use the answer you got previously to acquire the answer on this question. When they say hence, you must use what you got to find the answer for this question. And you have a term here, maximum value. I'm going to explain it to you later, guys. So let's just find the value, or let's just find let's just determine the maximum value of sin x plus cos x. How do you determine it? Simple, sin x plus cos x, rather this value, this expression here, equal to the square root of 1 plus. What's the value of k? Here's the value of k, sin 2x. Sin 2x. Simple, Now, let's define what is the meaning of maximum value. Maximum value. This thing, it causes you to draw the graph of sin 2x. And here, this is the function. This is the only function that we have on this side of sin 2x. So this function needs to determine the maximum value of it, meaning you must give me the value or on the graph of sin 2x, which value is the maximum on our graph. Let me draw the graph of sin 2x now, guys. The graph of sin 2x, let me just draw it. I'm not good at drawing, guys, but I'm trying, guys. I'm trying, shame. So perhaps this is going to be the graph of sin 2x. So the maximum value here is 1, guys. Then the minimum, if they say the minimum value, maybe next time if they say minimum value, we must have -1. How did I find them? It's simple. Let's just draw the box. Let's like when you draw the graph of quadratic or straight line or hyperbola. Let me just draw the box. I'm showing you for the sake of the future referencing here, guys, so you can understand good how did I draw the graph. I'm just drawing the graph of sin 2x. Perhaps let's use 45, 90, 135, 180. Then perhaps you are done. Then where I see x, I substitute 45. Where I see x, I substitute 90 to get y. Where I see x, oh, simple. This is the timeline I've chosen for myself. This is the x coordinates, or x degrees that I've chosen for myself. You can choose 30, 60, 90, 120, 150, 180, it's up to you, ne? But now I've chose 45, 90, 135, I've chose the 45 scale, 45 degree scale, ne? Simple. So for sine 2x, let's put in 45 on our x. Let's substitute 45. Sine 2 times 45 is 1. Then for 90, sine 2 times 90 is 0. For 135, we have -1. Then for 180, obviously we have got 0. Perhaps we have 0. Yes. Then where is our 45? Here's our 45. Where is our 90? Here is our 90, is 0. Where is our 135? Here's our 135, is -1. Where is our 180? Here is our 180, is 0. Then what is the maximum value of this graph? Is 1. What is our minimum value? Is -1. But the question says must determine the maximum value of sin x plus cos x. What is the value of k? What's the maximum value of sin 2x? Is 1. Let's put 1 here. Ne? Sin x plus cos x equal to the square root of 1 plus 1 equal to the square root of 2. We are done. Thank you guys. Like and subscribe for more content to follow. Have a beautiful day wherever you are. So if you need any clarification or clarity seeking question, just hit the comment button or text me on my numbers that I've posted on my wall, or my email is 2200319219 CUT@gmail.com. My WhatsApp contact is 082 866 758. You can get me there, guys. Have a beautiful day. Izwe maybe lethu. Africa izwe lethu. Thank you very much. Zwe.